the CME disappears from the quiescent component and becomes brighter and brighter in the CME component. Okay.
Is it okay here?
Okay, so I'll quickly explain. This is the original image. This is the dynamic component, and this is the quiescent component. So the quiescent component, when you remove these large CMEs, it certainly makes analysis of the large-scale 3D structure of the corona much easier. So we can use rotational tomography. But of most interest to us today is this component, which contains all the large CMEs and also a lot of small-scale stuff. So I'll talk, my result is based on the small-scale dynamics, but the next couple of slides, I'll just show off our ability to detect CMEs. So this is the LASCO C3 coronagraph, and these are the stereo Core 2 coronagraphs. And all these yellow points are automated points revealing structure in large CMEs. So this work is done by Jason Byrne, who works at Hawaii. The red points are the CME fronts. And as you can see, we have the ability to do this from 3 viewpoints. So this is right for 3D analysis. Actually distributed across position angles within the CME, and then all of this data is reduced into separate information on each CME. So this we should have a full version of this in a couple of months. You know? And I have to sort of... Anyway, I'm scared to move it. But my talk today is about the small-scale dynamics, and in particular these large system of expanding loops. And when you look, normally image processing to show dynamics in coronagraph images use time differencing, but that inherently amplifies noise in the image. But this method does not amplify noise, and suddenly you get a far clearer picture of what's going on. And stuff's going on everywhere. These ripples, you see systems of collapsing loops, for example, there. And it's a common feature to see these large closed loops arcing back to the sun. So I'll show and strong channel, showing a very active region at Berlin. There's a lot of flaring activity, probably associated with emerging flux. But you also have these large loops just expanding quietly, probably driven by this pressure. And over the course of 3 days, I see this system of expanding loops within the active region. They expand with a speed of about 10 kilometers a second, and then there's a huge eruption which destroys the whole system. To start with, then it becomes clearer and clearer, this system of expanding loops. There are some disturbances to the north, some ejections, and then the system becomes even brighter.
Is the solar polar axis straight up and down?
Sorry?
The polar axis of the sun?
Yeah, this is north. North-south. And now the system is very clear, and then it's destroyed by a huge eruption. So this expansion continues for about 3 days. It could be continuing for longer, but we can't see it unless it's above the limb. So we're limited perhaps to about 3 or 4 days.